Hello everyone, today we are going to share our red team practice of how to attack cloud native Kubernetes. As you can see, the trend of cloud native and containerization is coming rapidly. Security issues are becoming increasingly prominent. In this talk, firstly we will introduce the attacks against the cloud container infrastructure and new challenges to the red team. Then we will show the details of different attack techniques, and finally we are going to show the attacks we encountered during the construction of the cloud native red team. In addition, to let everyone get started with container penetration, we will also introduce our open source container exploitation tool called CDK. According to the honeypot data we collected from different cloud vendors, in 2020, we can see that attacks on traditional virtual machines are growing slowly. However, attacks on container infrastructure are increasing swiftly because, on the one hand, container instances are growing rapidly on public cloud. On the other hand, we do find some botnets are spreading using the vulnerabilities of containers. Based on the data we observed on the cloud, we noticed that botnets have increased their attention to container vulnerabilities in the past 2 years. Of the 25 cloud-oriented botnets observed in 2020, about 28% have its own container exploits, and the proportion reached 53 in this year. The figure on the right represents several common attack methods and representative botnet families, including the well-known Docker Hub backdoor image and unauthorized access to the public interfaces of Docker and Kubernetes cluster. It is worth mentioning that we found that in 2020, a botnet called BORG has integrated Docker escape vulnerabilities and the ability to produce Kubernetes lateral movement attacks, which means that attackers have paid more attention to the automated exploitation of the container environment. While the infrastructure used by enterprises is going to change, the red team's tech skills must also be innovated. Red teams generally divide the positions into two categories: the positions in the production network and the positions in the office network. For traditional IDC environment, the basic goal of penetrating production network is to get a shell of a server, and then we use different skills to collect the information, such as host live detection, port scanning, and produce the lateral movement to get other targets. But now, when enterprises build applications on cloud-native Kubernetes, after red team obtaining the shell of the production network through application vulnerabilities, is quite different from pawning an IDC server. This time, you will get a shell in a container with a slim environment and limited local resources. At this time, if the red team does not understand the security design and implementation of cloud-native technology, it will be hard to get the next stage. On the other hand, the methods of attack personal computers in office network are similar to the traditional skills, but the lateral movement from PC to production network will be very different. In IDC, staff usually depend on PAM, Jamf servers, and other devices that use SSH to log in and manage servers. But now, different applications are running in containers and use Kubernetes for deployment, scaling, and management. Developers are no longer use SSH for the operation, but through kubectl or secondary development tools like Dashboard with a web console. So the target of the red team on PC is searching the configuration file instead of the credentials of SSH or Jamf server. Of course, with the rise of DevOps technology, red teams can attack the internal DevOps platform to get their job done. These changes also brought new challenges to the red team. Before, arbitrary files with high permissions were almost equivalent to RCE on Linux, but this is no longer the case in containers. The information, lifecycle, and permissions of the container shell are extremely limited. In many cases, we don't have the permission to execute some commonly used commands, such as ptrees, strees, and you even need to install wget and curl. At the same time, Kubernetes will bring new container network, DNS, and security features. Obviously, the red team needs new knowledge, skills, and tools.
Okay, next, we are going to show our practical attack technique. Everything starts with a shell or container. You can get a container shell from some PHP application by a vulnerability like a PHP unit remote code execute CVE 2017-9841. After this, you will encounter a different environment from the IDC. Your purpose is to get more permissions of the entire service, such as obtaining permissions of other containers and pods, escape to the current node of Kubernetes, obtaining the master node, obtaining the API server, and even obtaining the cloud account where the hosting cluster is located. The attack service of cloud-native KA workloads is based on what resource can be accessed by the container shell we got in Kubernetes network. In the default Kubernetes container network, you can access more pods of other pod container, pods of the Kubernetes service, pods of the current node and other node, the service of the master node, and the component service of Kubernetes. In the past, our goal was mostly the agent master server, database of the SSH password, or IT automation master controller server, and so on, including but not limited to sort stack master, Ansible master. But in the Kubernetes network, this kind of centralized power is unified into API server, obtaining the domain permissions of the API server or the root permissions of the master node will announce the end of the war. Container escape is that the red team will try first after getting a shell of container. As so on this page, we catch out an RCE vulnerability in a PostgreSQL container. We can only obtain a limit process list and permissions restricted by cgroup and namespace. To better understand the method of a container escape, you should know that the process in the container is essentially just a normal process of Linux. All the behaviors of the process inside the container are transparent to the host. Therefore, the nature of the container escape is very different from hardware virtualization VM escape executing Kata container. In my opinion, the process of container escape is that a restricted process obtains unrestricted full permissions, or getting more privilege for process originally restricted by cgroup and namespace. It is much more closer to the privilege escapation in the Linux host. If you cannot escape in current container, you may have to think about other goals in the KA network. Normally, you try to get the following types of information. Information about the current pod, which namespace the current pod is located. Is that default namespace? Where is the current pod? What is the IP subnet of the node server? KA service and custom info can also be helpful in order to let everyone understand service and namespace better, and service DNS based on these two. Here are two simple examples. The DNS record above will be present in every KA custom by default, which corresponds to the Kubernetes service under the default namespace and point to the API server of the current cluster. When I create a new namespace named Tencent and then create a service named Force, the following DNS record will be generated. You can refer the YAML config file used to create the service on the right side. This YAML file comes from KA default service named Kubernetes. The four DNS records on the upper left are all point to this service. As mentioned above, we can easily obtain the namespace information of the current pod in the DNS configuration. Similarly, when we obtain a service IP or pod IP, we can also easily use the DNS reversal lookup to obtain the corresponding pod name, service name, and namespace name. Later, we will introduce multiple attacks against the node server of KA, and the IT information of the current node server will be obtained from the ARP cache tables from the current container. The default service and the Kubernetes namespace, such as the private version Kubernetes service in default namespace and IP point by Kubernetes, can also be used to infer the IP subnet of KA service. With the above information, you can start host discovery and pod scanning. Of course, if you want to carry out this kind of behavior, you need to know the rule of the security system used by the target company in advice, such as HIDS, EDR, and NIDS. Under normal circumstances, if you have the root permissions of the container, the method of pod scanning is almost the same as the traditional IDC. What you need to pay attention is, if the KA cluster uses services such as Istio, then translation method will bring a wrong result. How to judge whether the cluster is using Istio or not? You can use CDK run Istio check to detect now. Its detection logic is based on Istio inject into the metadata of the HTTP request header. According to the metadata, and decode it. You can even get a lot of information about current pod and the KA cluster, which is difficult for you to get on an ordinary KA network. The picture on this page describes why the Istio network is special. All your requests and responses will be hijacked, proxy, and management via the sidecar container of Istio. The request you send and the response you receive will be changed. If you want to perform point scanning in Istio network, we think the best practice is to use tools like a map. Only use ICMP feature to do host discovery and determine whether the point is open by the application layer detection. After obtaining the results of the pod scanning, which service are noting my words, the result we got can be divided into three types: pods on KA pods, pods on node server, and pods from Kubernetes service. This page shows the role of each key component when user execute commands with kubectl, including API server, Kubernetes, Docker, KA dashboard, kubectl proxy, subcommand, and etcd. The role of the components correspond to the risk if those services are controlled by the red team, and those components are easy to unorchestrated configurations in the private network. Except the above, obtaining the certificate, API key, password, and token about KA component in the private net is also the way we are going. If you really cannot find a target in the private network, you may try the cloud-native API gateway or the current cloud-native API gateway open source solution do not have a complete authentication function like KA, with the feature of the flexibility, dynamical, and remote config. Many projects of solution in the open source branch can access admin API in the remote. The second most popular API gateway project, API 6, have a default access key, and the red team can easily get a shell by running a Lua code. When we control the API gateway, we can connect, control, and hijack the north-south traffic, which is management by cloud-native cluster. More importantly, obtaining the API gateway can break through the elimination of network isolation and get access of the other private network and public network. The same reason for container escaping. After the red team obtains custom permissions, generally they are not satisfied with the only obtaining the permissions of pod and containers. The red team will create pods and containers start with privilege to obtain node permissions, which are used to obtain the full permissions for container process and node process. You can use the node select label to select the target node server and get a root shell, except the master node. If you want to find some credential of a cloud account, you can find it in the following patch. The multi-files, the Kubernetes cert by kubectl get YAML result, the hardcore AK in project, the etcd, the cloud platform features, the cloud metadata API, and the KA port in master node. Now we are gonna share a real-world case of Tension Red Team in 2020, which contains a lot of cloud-native and container-related knowledge. This time, our goal is a company engaged in the financial industry. All their online applications and office applications are all running on Kubernetes. They hope to access their overall security conversion results from the public network to the private network. It is not aimed at employees not using phishing, but only using vulnerabilities to obtain their custom permissions, which are any interaction with staff. We found that they built a self-developed zero trust system so that employees can work at home and on their mobile device. This is our first breakthrough. After investigation, we found that all the private domains of the target company are all in the subdomain which is email.com, and some private domain can also be pasted on the public network. They are all in the CNA account point to a gateway on the public network, just like below. But if the red team directly access the private OA domain from the public network in a browser, it will return forbidden, which is HTTP sentence code 403. All the HTTP requests from staffs in the tech company want to pass the gateway and access the OA website for work. Two things are required. One is the VPN client and the others is the session token indicating the staff's identity in the HTTP request key. About the staff identity, we got some AD credentials of the employees by brute force cracking of the Microsoft Server Active Sync, which is exploited on the public network. However, we have been unable to get the application of the private VPN client for a long time. We began to analyze the security issues in this design. Imagine that ztgateway.email.com is open on the public network. What is the method of the listing the source IP of the HTTP request? Is that VPN client important? So that I try to find the HTTP request we send to Zero Trust Gateway and set some HTTP header values to different private IP, such as the client IP, header about forward, and remote ADDR. In the end, I found that when the HTTP request sent to the Zero Trust Gateway, carry which the forward 4 HTTP header, and the value is a private network IP start with 10. Then we can access the OA login page. Coupled with the employee identity that we got in the Microsoft Server Activity Sync, now we can access the network of the target OA. The Office network is a new world. After long explorations, we finally found a new breakthrough in web service for serverless. Domain name is serverless.email.com. When the URL of a new Git project is provided to the web service, serverless service will have a public container to crawl and download the project code, install dependencies, and refactor. This is a very imaginative feature for us. We found that there are several ways to get a shell in this container. First, container inject in URL permanent when git clone execute. Second, when install Node.js dependency package, construct a special package.json file to control the public container using methods such as pre-install. Also, enable Python package and using the low-level issues of git clone, git submodules, and go-get can get a shell too. All in all, we got the root shell of this public container and found that this container starts with system admin capability. There are many escape methods suitable for this type of container. Now you can use our open source tool CDK to detect and escape such container easily. Use CDK evaluate to detect capabilities and use CDK run rewrite cgroup device or CDK run multi-cgroup subcommands to escape this container. Now we can access files and get a shell in the node server of the public container. Great. We know that all agents that acting on containers should run on the host, CDK containers, or daemon-side containers, which privilege. We define lots of self-developer agents on this host, and we found a very interesting agent named CLI Web Controller Agent, and got his binary project, CMD lines, and config files. The program is written by Golang, and we know that this agent is to support web controller features. How do the developers in the target company manage their containers? It is through the web controller feature that you can call bash in the container to execute commands in the web controller. The agent will listen on port 3333. The following HTTP request can create a session of document exec subcommand. In the end, the agent actually calls the default local Unix socket of Docker. You can see a simplified process of creating a web controller session in the lower left corner of this page. But how should we get all the container IDs with 64 characters on each server? This is obviously impossible. But the man who was using Docker container knows that we can replay the entire container ID by using the first few digits of the container ID. In Docker Unix socket, this feature is also supported. For example, if only 2 containers on the host like below, one up in 4 months ago, the other one exists in 2 days ago, or their container ID start with C. Request of different container ID will return different results, including the following 3 results: container ID multiple, container ID not found, container ID not studied. So we can use Docker sort ID feature to fetch all container sort ID on all node server of Kubernetes cluster. Since we can get a shell of all containers on the Kubernetes clusters, now we focus on another agent. It is an agent that connects logs. It uses demo set to deploy and runs on all KA node servers. It uses a KA demo set YAML file like this. This is almost the default setting in the official refer of Elasticsearch bits. Many escape tricks can work here. It is both privileged and mount the root directly to the container for logging. Obviously, we only need to use the 3333 port of web controller agent about to control the container started by this demo set and escape to get a root shell for any node server. And this demo set ensures that all Kubernetes nodes run a copy of the port. All nodes of this cluster are in our grasp now. In the end, we achieve our goal and we can control all the resources of the tech company on the cloud. Here are some simple tips. First, we should pay attention to the kubeconfig file and its permission. Second, it's important to obtain the security ID and security key of the cloud API. Third, in this case, we got a master node shell and the admin kubeconfig files of KA cluster in the last. Fourth, after escape, the node shell allowed us to do more things. Finally, although we did not have a CDK at that time, it is much more convenient to use tools like CDK.
Okay, by now we talk a lot about how to identify and exploit container vulnerabilities, which is quite a common problem in red team. So with that problem in hand and particularly think about the automation, we created a tool called CDK, written in Go and released as a binary It's not a framework, it's a binary to do the auto-pump stuff inside a container or Kubernetes pod. It helps us to perform container recon, Linux pod exploitation, and later movements in Kubernetes cluster. And I did make the GitHub repo public available, so you can find exploits and examples over there. It contains 3 main functional modules. After we hack into the container, upload the CDK into that container, and then we use the evaluate command to find the weakness in current environment. It will automatically obtain the fingerprint, sensitive information, and vulnerabilities inside the container. Then we can search for corresponding exploits based on the weakness evaluated by the tool. The exploit module integrates dozens of commonly used container attack exploits, which can automatically complete operations such as container escape, extraction, persistence, and later movement in the Kubernetes cluster. In addition, we also restored some Linux commands and network tools commonly used in pentesting to facilitate the penetration process in any slimmed container image. In the current major release, we added a lightweight version for CDK. It's prepared for short-life container shells such as serverless and functions. We added build tags in source code and cut a few exploits to make the binary lighter, just a 2 MB file, but contains 90% of CDK exploits. You may also pick up useful exploits in CDK source code to build your own lightweight binary. So that's a brief introduction of how to attack cloud-native Kubernetes. Thank you for your time, and the slides will be available on conference website. Hope you enjoy watching it. Any feedbacks or new ideas about container exploitation, you can post it to online chat box or create an issue in our GitHub project. Again, thank you so much.